guy don't work for weather before. I tell you. Ah, which kind?
It's an experience. Well, we don't do this. I'm telling you, without CV. Put up for your job. When you come out, put up for your job. Na tattoo. Chop on this place. These are called way. Then you not file it very well.
Lathe machine is a machine for shaping wood, metal, or other materials by means of a rotating drive which turns the piece being worked on against changeable cutting tool. Or a lathe is a machine tool that is used primarily for shaping metal or wood. It works by rotating the workpiece around a stationary cutting tool. The main use is to remove unwanted parts of the material, leaving behind a nicely shaped workpiece. Types of lathe machine: we have the center lathe or engine lathe machine, the speed lathe, we have the capstan and two-reed lathe machine, we have the two-room lathe machine, we have the bench lathe, we have the automatic lathe machine, we have the special lathe machine, and we have the CNC lathe machine. Now let's talk the main parts of lathe machine. The main part of lathe machine are the bed, the headstock, the tailstock, the carriage, the legs, and feed mechanism. Let's talk about the bed. The bed is of the lathe machine on which all the other major part lies. The bed of a lathe machine is strong enough to resist vibration due to cutting forces, and it is made with cast iron. Let's talk about the headstock of a lathe machine. The headstock provides the power required for rotating the work at various speeds. It provides attachment facilities for job holding devices such as choke and drives, and also it provides the spindle and provides provision for a rotating lever center. Let's talk about the tailstock of a lathe machine. The tailstock of a lathe machine is mounted at the right end of the bed. It is opposite in position to the headstock. The hand wheel is used for lateral movement. It is also used for attachment of tool like drill, tap, etc. This tool or the dead center can be attached at the front of the spindle, which has a tapered hole. Let's talk about the carriage of lathe machine. The carriage of a lathe machine is a part that provides attachment whose function is to support, guide, and control the cutting tool. There are main parts of the carriage of a lathe machine. Now we have the saddle, the cross slide, the compound rest, the two posts, and apron. Talking about the saddle. The saddle slides between the headstock and the tailstock. It carries the cross slide and the two posts. Still on carriage of lathe machine. Talk about the cross slide. The cross slide is mounted on the saddle and support the compound rest. The cross slide is also used to move the cutting tool in a perpendicular direction to the axis of the lathe. It moves using a feed screw. The hand wheel controls the feed screw. Still on the carriage of lathe machine, we have the compound rest. The compound mounted on the cross slide. It supports the two posts. The compound rest of a lathe is used for obtaining angular cut, short tampering, as well as to position the tool. The base of the compound rest is graduated in degree to indicate its current angular setting. The tool post itself. It is mounted on the compound rest and supports the tool. The tool post job is to hold the tool in place and to enable us to adjust it in a convenient position. Lastly, we have the apron. An apron is attached to the saddle where it hangs. The apron contains gears, clutch and lever for operating the carriage. There is a hand wheel for manual movement of the carriage. Still on the main part of lathe machine, we mentioned leg. Now let's talk about the legs. The legs are the support of the lathe machine. They carry the entire load of the machine. Number 2, the legs are made up of cast iron. They can be secured to the ground using bolts for extra stability, and the left hand leg houses the electric motor, the feed mechanism of a lathe machine. The relative motion between the tool and the work is known as the feed. So the feed mechanism consists of all the parts that causes or supports this relative motion. The carriage is a part of the feed mechanism. Similarly, the gear, the lever and the pulley, which transmit motion from the headstock spindle to the carriage, are all parts of the feed mechanism of the lathe. We have 3 types of feed. We have the longitudinal feed, the cross slide feed and the angular feed. Let's talk about the longitudinal feed. Is when the tool move in parallel to the lathe axis via a carriage. The cross slide, when the tool moves in a perpendicular direction to the lathe axis. We have the angular feed, when the tool moves at an angle to the lathe axis with the help of compound rest. And what are the 3 cutting parameters of lathe machine? We have the cutting speed. Let's talk about the cutting speed. This is the speed at which materials is removed by the tool from the workpiece. It's generally expressed in meters per minute. In lathes, the cutting speed is obtained from the rotatory motion given to the work. Talk about the feed. It is the distance which the tool moves for each revolution of the work. We express it in millimeter per revolution. Still on the parameters, we have the depth of cut. That is the last. It is the depth of penetration of the tool into the workpiece during machining. It is usually expressed in millimeters. In a lathe, depth of a cut is the perpendicular distance between the machine and unmachined part of the work. Now, talking about the operations done on a lathe machine, we have the turning operation, facing, chamfering, parting off, knuckling, drilling and riming, boring, thread cutting. Now let's understand each of these operations one by one. Turning. In turning, 2 sinters support the job. That's for number 1. Number 2, the job rotates on its own axis. Number 3, the tool is fixed on the tool post. Number 4, in this operation, the diameter of the work is reduced due to the relative motion between the tool and the job to a desirable dimension. The tool moves in parallel to the axis. Number 5, if the diameter reduces uniformly throughout the length of the work, it is known as straight turning. Number 6, Number 6. When different diameters are obtained over the length, it's called step turning. Then number 7. If the diameter is reduced in an angle, it is called tamper turning. Number 8. Shoulder turning, eccentric turning, and rough turning are the other 3 types of turning operation. So we have so many turning operations in turning processes. Now let's talk about the facing process. Number 1. In facing, 2 centers support the job. The job rotates on its own axis. The tool is fixed on the 2 posts and it is head slightly inclined to the job, though its motion is perpendicular to the axis of the job due to cross slide. Number 3. In facing operation, the end of the work are made flat and the length of the job is reduced. Number 4. The cutting tool moves perpendicular to the job. Due to the relative motion between the job, part of the job gets removed in the form of chips. Chamfering process. The job supported by 2 centers and rotates on its own axis. Same process. The tool is fixed on the 2 posts. Its head at a small angle to the job and moves perpendicular to the job. Due to the relative motion, the edge of the job undergoes tapering. The edge of the job undergoes tapering. Chamfering is a safety feature. It is done to make sure that the sharp edges of something don't harm anyone who is handling the job. Parting off. The job is attached to a choke. It rotates about its own axis. The parting tool is mounted on the 2 posts and the feed is perpendicular to its own axis of the job. Okay. Parting tool is mounted on the 2 posts and the feed is perpendicular to the axis of the job. Number 4. In parting off, we remove a part of a particular length from the remaining job. Talking about knurling. The job is supported by 2 centers. It rotates about its own axis. Knurling operation is done to provide some grip on the job. Example, like watch turner. The knurling tool is kept on the 2 posts and pressed perpendicularly to the pattern of the ruler are formed on the job. Note that materials is not removed. Knurling only creates an impression. Drilling. The job rotates about its own axis, but the tool is fixed into the tailstock instead of the 2 posts. Number 2. In a drilling operation, a hole is made into the job. Number 3. The drill is fed along the axis of the rotating job, and due to relative motion, we get a hole of a desirable diameter. Riming. After drilling, riming is a process where the hole undergoes correction to a desirable size. A small amount of material is removed in riming. Boring operation. The job is attached to a choke. The job rotates on its own axis. Number 2. The boring tool is fixed to the 2 posts. Number 3. In the boring operation, an already drilled hole is enlarged through relative motion between the job and tool. If an operation is carried to a certain length of the job, it's called counterboring. Thread cutting. Thread cutting is an important operation where helical grooves are produced on the job by feeding the tool longitudinally on the rotating job. The longitudinal feed should be equal to the pitch of the groove. Automatic movement of the carriage is required for constant pitch. Work is hid between 2 centers and rotates about its own axis. Now for the thread cutting, note Longitudinal feed is equal to pitch divided by revolution. Now, the ratio of longitudinal feed to the speed of headstock spindle should be such that the relative speed of work and lead screw cause the growths. Number 2 point. The change gears are used to engage relative motions between the lead screw and half nut, achieving automatic movement of the carriage. The speed of the lead screw controls the pitch.